So firstly, we'll go through the overview for the 6th week, followed by a practice assignment, and then we will take the doubts. So moving ahead, so coming to the 6th week overview for this week. So first lecture, it was about the vehicle routing. So what are the factors that we need to consider in vehicle routing? So this is concerned with the traffic congestion. So we should avoid the areas where there is high traffic congestion. We should not prefer U-turns. In India, we should prefer left turns. So there are other factors such as routing coefficients which incorporate the traffic congestion. So these are the multiple things that were discussed within this part. Then we had the pickup time concept. So within this, we have separate components. So we have the haul time, we have the unloading time or the side time as it is called. Then we will have the actual pickup time, so which is needed for collecting the waste from the houses. So there are different components and all of them together form the overall round trip. Then there was lecture 2. So based on the vehicle routing factors and the pickup times, we designed the collection system. So basically how many trucks we require for collecting the waste from the city. Then there was collection route topic. So how to like decide the routes on which the trucks will ply for collecting the waste and which should be optimized. Followed by this, we had lecture 3. So here we reviewed the status of solid waste management in the different smart cities. So Ahmedabad, Vizag, Bhopal, Udaipur, Indore, New Delhi Municipal Corporation. These were the cities for which the status of solid waste management was discussed. Then we had lecture 4. So here the primary topic was biological treatment of biodegradable waste. Then what are the different biochemical processes that are there, which need to be done or which happen during the biological treatment of solid waste. Then we had lecture 5. So that was about aerobic composting and environmental factors that affect composting and digestion. So let me follow this from the first question. So question 1. Which of the following component is destroyed during biological treatment of municipal solid waste? So the given options are residual volatile solids, biological volatile solids, inorganic, and none of these. Let me just check if someone is waiting in the. Okay, so yeah, still okay. Continue. So this is about which of the component is destroyed during biological treatment of municipal solid waste. So there will be different components in municipal solid waste when we talk about the biological criteria. So there will be firstly residual volatile solids. There will be biological volatile solids. We will have some fixed carbon. And finally, after everything like combustion and everything is done, so we'll be left with ash. So this is usually happens after we have processed the waste to energy plants. So here we are concerned with the component which gets destroyed during the biological treatment. So we can see that since we are concerned with biological treatment, so it cannot be inorganic. Then we are left with residual volatile solids and biological volatile solids. So residual is something which is left over. So this is not something which will get destroyed. So this will be what we will be left over with finally. It is volatile, but it it won't be like it won't get degraded. So we will be left with biological volatile solids. So that is option B. So we'll see this using the slide also. So answer was option B. That was biological volatile solids. So students can refer to the fourth lecture of this week for this question. So here we can see the composition of waste. So we have the biological volatile solids that is indicated by the blue color, a light blue color. And then we have residual volatile solids, the green color. Then we have the inorganics, and finally we'll have some moisture as well, that is water. So biological volatile solids they represent the organic fraction of the biodegradable components and they get destroyed during the treatment. So this should be remembered. Residual volatile solids are also organic. They are also biodegradable, but they will still remain after treatment. And this will also include some plastics. Then we will have inorganics. So that will be like glass, metal, dirt, silt, those things. So that cannot be integrated and we'll have some moisture as well. So these are the four components. So the organic fraction which will get degraded will be the biological volatile solids, also called as abbreviated as BVS. Coming to the next question. So this question is a poll. So you can see the table. So I'll just read it if it is not very visible. So on the left hand side, we have volatile combustible matter, water content, and fixed carbon. On the right hand side, we have lost when heated to 105 degrees Celsius for 1 hour. The second one is combustible residue after volatile matter for 550 to 950 degrees Celsius. And the third is ignition at 450 degrees Celsius. So you have to basically match the proximate analysis parameters with their determination procedures. So here we have the parameters. So fixed carbon water content, and here we have like how do we determine them? What is the procedure that is adopted? So the given options are, you can see, I hope. So we have to basically match the left side with the right side. So I'll just drop a poll. You can answer it in the chat also. This is question 2. I've lost the poll. You can answer it. So someone has said C. Give you maybe 2 minutes for this, then we can discuss this answer for this question. Any more responses? We have one response in the chat and one response in the poll. Then if you are not sure about the correct answer, I encourage you to answer so that at least you will know what mistake you did. Yes, so we have one response in the chat, one response in the poll. So we'll discuss the answer. Let me just end. So yeah, let's just start from the basics. So firstly, we have volatile combustible matter. So this is something uh, that will exist up to certain temperature. Like initially, there will be some moisture that will go away. After the moisture, there will be the volatile matter, and finally, there will be some fixed carbon, so that you cannot remove easily. So firstly, at lower temperature ranges, we should have some volatile combustible matter that will get removed or get ignited. So here we can see we have 105, so and then we have 550, then we have 450. So the middle range, that is for volatile, that is for ignition at 450. So one will go with 3. Then we have water content. So as you will be knowing, so boiling point of water is around 100 degrees centigrade. So water content, once you like heat it to 100, or we go little higher just for to be conservative. So we'll heat it, so water content will get lost. So 2 will go with 1. So lost when heated to 105 degrees Celsius for 1 hour. So we'll heat it for little higher than 100 and we'll lose all the water content. Then we will be left with some fixed carbon. So that also will get combusted, but the reason will be like since the temperature for that will be quite high, so it will be around 700, 800 degrees Celsius. So it will exist after the volatile matter has been removed. So 3 will go with 2. So let me just write it again. So 1 went with 3. We had water content, so that will go at 100 degrees. So that was 1. Then 3 went with 2. Yeah, so it will be 3, 1, and 2. So we have 3, 1, and 2. So that is in option C. Option C is the correct answer. Discuss this using the slide also. So option C was the correct answer. 1 with 3, 2 with 1, and 3 with 2. So students can refer to the fourth lecture of this week. So if we talk about organic matter, so that will compose around 30 to 80%. The major part will be organic matter, you can say, of municipal solid waste. So if we do approximate analysis, so that will help us determine the different parameters. So firstly, we will have water content. So that will get lost when we heat it to 105 for 1 hour. Then we will have some volatile combustible matter. So that will get ignited at 450. Further, we will have fixed carbon. So from 550 to 950, that will be fixed carbon. And finally, we'll have some ash. So that will be non-combustible residue. So there are different components. So we should know like what are the temperature ranges and how they get removed progressively. Moving on to the third question. So question 3, which of the following compostable material has the, so compostable means something which can get composted or something which can participate in the composting process. So has the highest carbon is to nitrogen ratio. Options are cow manure, yard waste, digested sludge, and newspaper. So different things will be there in municipal solid waste. So different components will be there. So there will be some components C1, C2, C3. So each of them will have a certain carbon is to nitrogen ratio. So depending upon this ratio, we will mix them together so that we can get a optimized carbon nitrogen ratio for the process of composting. So generally it will be like 20 is to 1 or something like that. We should try to maintain in that range. After that range, below that range, the process will not be that good, or like it will not go as desired. So when we talk about higher carbon nitrogen ratio, so paper products will usually have high carbon. So carbon will be very high, and compared to that, nitrogen will be very low. So if we have increased the numerator and decreased the denominator, so what will happen is the overall value, that is the ratio, will increase. So generally it is seen in paper products that this C is to N ratio will be quite high. So here we can see cow manure, it will not be there. Yard waste will contain basically the leaves and weeds, cleaning from whatever is the garden and all that. Digested sludge, although it will have a high value, but it won't be as high. Finally, we'll be left with newspaper. So this will have quite high carbon nitrogen ratio. So we'll see the values in the next slide. So option D is the answer. Newspaper. Students can refer to the last lecture of this week for this question. So here we can see the nutrients. So here we can see 20 is to 1 and 25 is to 1. So we should try to maintain between these two values the carbon nitrogen ratio. So it is one of the critical factors for composting. So relative proportion it indicates, because above, when we go above 40 is to 1, the composting time increases. So digested sludge, we can see it has a low value, 15 is to 1. Yard waste, usually high values it will have, because more organic content is there, more carbon is there, basically it will be leaves. So 40 is to 1, 80 is to 1. Then newspaper will be like quite high, very high. It will be like, even in some cases it has been seen that it goes up to 200 is to 1 also. So this is like averaged out value. So 175 to 800. So this is the minimum and this is the maximum. So maximum will be generally like low quality newspapers. So like cheap newspapers will be there. So local newspapers. So they will have very high carbon is to nitrogen. Compared to that, like good quality newspapers will be there. So their paper will be like somewhat better in quality. So their CN ratio will go down. So to achieve an optimal ratio, we blend the waste together. So we'll mix different wastes so that we can get the optimized carbon is to nitrogen ratio. Moving on to next question, question 4. So what should be the range of moisture content on a wet weight basis for composting of the waste? So options are 10 is to 30%, 50 to 60%, 45 to 80%, and 20 to 30%. So the thing is, in composting, it is a aerobic process. So what do we need? So we need the organic matter, we need air since it is aerobic, and we'll also need moisture. So this is because the microbes that participate in the process of degradation, they prefer humid environment. Humid means there should be moisture. So it should not be very low, because if it is very low, the efficiency of the process will reduce. If it is very high, that also is not good, because the microbes, they prefer like a optimized value somewhere in the between. So it will be like we should not go very low. So very low is nothing but 0. We should not go very high. So 100. So we should be somewhere in the middle. So around 50 to 60% we should try to maintain. So that will be option B. Actually, this is a statistic that you need to remember, but this is how I used to remember it. So we should be try to like, we should maintain it somewhere in the middle. So not very high, not very low. So 50 to 60% is the ideal value to maintain for composting. So option B was the correct answer. You can refer to the last lecture of this week. So there are certain environmental factors which affect composting. So first is moisture content. So it should be in this range, 50 to 60%. So what happens is it displaces the air from the pore space. So how does the water come in the waste? So that is basically from sludge. So sludge will usually have more H2O. So this is not very related to this. So we'll discuss this in the next, some other question. We'll discuss the topic of seeding. This also is there. Moving on to question number 5. So if the pickup time per trip for a waste collection vehicle is 2.7 hours, so H here indicates hours, just to make it clear. At side time per trip is 0.4 hours, and you have to complete your round trip in 4.1 hours. So what would be the haul time allowed per trip in hours? So I think there should be options for this. Yeah, so 1.5, 0.7, 1 and 0.5. So that will be the formula. So T will be equal to P plus S plus H. So T is basically the round trip time. So that is T. P is the collection time. S is nothing but site time. So the time which we will spend for unloading at the landfill. And this would be the haul time. So like, so there will be the city. So we have to haul it to the landfill, back to the landfill. So that those will be basically haul time components. So here round trip time, has it been given? Yeah, that is 4.1 hours. We just write it. So T is 4.1 hours. What else do we have? So we have the site time. So that is 0.4 hours. So S is zero point 0.4. Haul time. Okay, so that we need to find. So H is not given. And do we have anything else? So yeah, so pickup time or collection time is 2.7 hours. So P is 2.7 hours. So we have the equation, four variables. So three we know. So fourth one we can easily find. So it will be 4.1. That is T. P is 2.7. S is 0.4. And then we finally have H that we need to find. So H will be, I think, 4.1 minus 3.1. So it will give H to be around 1 hour. So hold time is 1 hour. So which is this option? C is the correct answer for this. So option C was the correct answer. That was 1 hour. You can refer to the first lecture of this week for this question. So for hauled container systems, so we will follow this equation for collection. So we'll have the timing for round trip, that is T. P is the pickup time. We'll add the site time to it. So landfill, transfer station, whatever time takes for loading and loading. Then we will have the haul time per trip. So we'll add these three components and that will give us the overall time for the round trip, that is T. Moving on to question number 6. So this is a poll. So I'll read the question, then I will post the poll. So to obtain a carbon nitrogen ratio of 40:1, how much sludge has to be mixed with 1 kg of leaves? So it has been given the carbon nitrogen content. So 1 kg of leaves has 0.35 kg and 0.007 kg. So it will be carbon and nitrogen. Then carbon nitrogen in 1 kg of sludge are 0.2 kg and 0.04 kg respectively. So first carbon has been given for leaves and then nitrogen for leaves, then carbon for sludge, nitrogen for sludge. Options are given 0.3, 0.08, 0.2 and 0.05. So you can start solving this. It may take some time. So I'll give you maybe 2 to 3 minutes for this. Maybe 3 minutes will be enough. I'll just drop the poll. Question 6. I have launched the poll. You can also type in the answer in the chat also. Take your time. No, no hurry. Take your time. Try to answer it correctly. So the intention of this question is to know like how you should mix two different kinds of waste so that you can get an optimum carbon nitrogen ratio for the process of composting. So you will have some base material, like here the base material is leaves. So we know the ratio for leaves. So we'll try to determine how much we should mix other kinds of waste to it so that we can optimize the ratio. So someone has answered B. Do we have any answers on the phone? So one response in poll and one response in chat. So do we have any more answers? Okay, so two responses only. We discussed the answer for this one. So what is the given data here? So we have carbon nitrogen ratio 40 is to 1. So this much we need to obtain finally. So this is our end value. We have been given 1 kg of leaves and we need to find how much sludge we need to mix with this 1 kg of leaves. So there will be a carbon nitrogen ratio for the mix. So this will be basically what? So there will be some carbon in the leaves. There will be some carbon in the sludge. This we should divide by nitrogen in the leaves plus nitrogen in the sludge. So since we are mixing two types of waste, leaves and sludge, so the carbons will get added, the nitrogens will get added. So we are not considering any kind of biological or chemical reaction to happen just now. So since we are quickly mixing them, so we are not assuming anything of that kind. So the carbon and nitrogen will remain in their virgin form. So we have the carbon for leaves, carbon for sludge. So that will be the overall carbon for the mix. Then nitrogen for leaves and nitrogen for sludge. So for the mix, how much is the value? So for the mix, we have 40 is to 1. So this is the carbon nitrogen ratio. Then we know the amount of leaves. So we have 1 kg of leaves, and in 1 kg of leaves, carbon is 0.35 kg. So that is 0.35 plus. We don't know the amount of sludge. So let us assume that, let's say we have 1 kg of leaves. We mix x kg of sludge to this. So since we don't know the value, we need to assume something. So we'll take it as x. So x, so 1 kg of sludge had 0.2 kgs of carbon. So x kgs will have x into 0.2. So we are done with the carbon part. So that was the numerator. Then we need the denominator, that is nitrogen. So in leaves 1 kg we have 0.007 So that is nitrogen in the leaves. And then finally we need nitrogen in the sludge. So we have x kg of sludge and we have 0.04 kg of nitrogen. So this is 0.0. So let me do the calculation. So it will be 40 into 0.007 plus x into 0.04. This will be equal to 0.35 plus x into 0.2. So this will come out to be 40 into 0.007. So this is 0.28 plus this is 40 into 0.04. This is around 1.6x equals 0.35 plus x into 0.2. So this will be around 1.4x, and then on the right hand side we will have 0.07. So 0.07 divided by 1.4. So let me just shift it here. So x will be around 0.05 kg. So it will be around 50 grams. Yeah. What is the unit they have asked? So no mention of the units. So I think we should take it in SI units only. So let's say it is kg. So everything is in kg. So let's report the answer in kg. So that will be 0.05. That is option D. I hope it was clear. So if anyone has any doubts, you can ask. I'll just wait for a few seconds. If you have any doubts, you can ask. Else I will move forward. I don't think anyone has any doubts. You go ahead. So the answer was option D, 0.05. You can refer to the last lecture of this week. So same solution, similar solution like I have put it here for reference. So we had the carbon in 1 kg, carbon in sludge for 1 kg. We operated it with x, we divided by the nitrogen. Finally, we'll get around 0.05. So here I have not solved it completely. So you can refer to the steps in the previous slide for the complete solution. Moving on to question number 7. So to minimize the loss of nitrogen as ammonia, NH3 gas, pH must be below which value during composting? 8, 5, 8.5 and 7. So what happens is, let's say we have nitrogen in the waste. So once the pH goes more than 8.5, so this starts getting converted to NH3 ammonia. So basically it starts escaping the waste. So that we don't want to happen. So why we do not want to happen? So this is composting. So composting we need a optimal carbon nitrogen ratio. So if the nitrogen starts reacting, starts changing to any other compound, so that is not good for the composting process. We need this value to be like as balanced, as stable as possible for the process to be process to go on as desired. So to obtain this optimality, we need to ensure that the pH does not go above 8.5. So we should try to keep it as much below as of this as possible. So answer will be option C, 8.5. So moving on, we'll discuss this during the slide also. So option C, 8.5, you can refer to the last lecture of this week. So here we can see so this is the topic of pH control. So pH should be like basically it is the measure of acidity or alkalinity. Mesophilic stage, we should maintain between 7 and 7.5. Thermophilic, it will rise to around 8 due to the heat. So to minimize the loss, we should try to keep it below 8.5. So how can we do this? We can provide air. So how do we provide air? So we do mixing of the compost. So it will be a gradual mixing. It should not be very rapid. For gradual mixing, we can increase the amount of air. So that prevents the formation of this ammonia gas. So moving on to question number 8. Which of the following statements are true for designing pickup routes for Indian cities? No U-turn. U-turn is preferred. Right and left turns are equally preferred. And the final option is right turns are preferred. So just explain using a simple diagram. So let's say we have some like a, let's say a residential area here. We have a residential area here. Let's say this road is divided, so you cannot directly turn. So you need to go to some place called as a diversion. So where there will be a breaking in the divider or a proper signal you need to go to. So let's say a truck comes here, collects the waste from here. So now what? Let's say it wants to collect from here. So it has to go and take a turn here. So that is like a U-turn. But what is the problem with this? Because there will be traffic from this direction which will be coming. So it will obstruct that traffic. Plus these trucks will be of like quite large size. So these small openings, they may not be favorable enough for the turning of a truck. Also, like it is not easy to turn a truck. It's a big vehicle, so you need to have spacing. You need to like you'll certainly block the road for quite some time. So that can lead to some nuisance. So you should avoid U-turns. So who will collect the waste from here? So there will be some other truck which will be collecting, say, the waste here. So that can come from there and it can collect the waste from here. So we should try to avoid this U-turn as much as possible. So if it is unavoidable, we need to do it. But anyway, we should try to avoid. Then when we talk about, let's discuss that since the options contain turns also. So not this right and left turn. So let's discuss that also. So let's say there is a side road here. So this truck which was going this way, this can easily turn this way. But if the same right turn was somewhere here, so that would have been much difficult to do. So left turns will be preferred over right turns. This is the Indian scenario. If we talk about abroad, so I think most of the world drives on the right. So for them, they will prefer right turns. But I think the Commonwealth countries, which includes I think India, UK, Australia, some African countries. So wherever the British were there, so there we have the left side driving. So there we prefer the left turns. Other world, right turns. So we should be clear about this. So in this course, we will stick to left turns because we are talking about the Indian scenario. So which of the following statements are true? So you should not take any U-turns. So U-turn is not preferred. So second option is incorrect. Right and left turns are equally preferred. No, this is also not correct. We prefer left turns over right turn. The right turns are preferred. No. So the answer is option B. So should not try to take a U-turn. So you can refer to the first lecture of this week. So what are the factors in designing these pickup routes? Comes under the topic of vehicle routing. So we should consider the loading times. We should avoid U-turns. We should prefer right turns. So as I said, so this is for the scenario abroad. So other countries where there is right hand drive. So this is from the EPA guidelines. So that is from the US. So they have this right hand. So to maintain consistency, it was kept as right turns itself here. So volume per truck, that will be the compaction rating, how much waste we can compact. So more we can compact, lesser trucks will need, then the travel time to the transfer station. Going ahead to the ninth question. So this is a poll. So we have been given the a table here. So we have different components of waste: paper, cardboard, cloth, newspaper, and some other compost material. We have the percentages 20, 15, 3, 30, and 32. Then we have the respective moisture contents 5, 3, 4, 3, and 55. So the other compost material has quite some moisture content. Around half of the moisture content is in the final component itself. So we have been given the physical composition. So what is the physical composition? So this is this value. So the percentage, and then we have been given the moisture content. So of collected municipal solid waste. So we need to find the moisture content of the waste. So the whole mix, what will be the moisture content? Each component we know. So how will we find it for the whole mix? Options are 20, 30, 15, and 40. So I will drop a poll. This is question 9. I will give you around 2 minutes for this. Try it out and let me know the answer. So I've launched the poll. and try it out. No answer still now. Why is that the case? Okay, so someone has answered in the poll. We'll wait for a few more seconds, then we'll discuss the answer. So I will end the phone. Let's just answer. So this is based on the concept of weighted average. So even like just let's talk about a general scenario. So we have different people. So X, Y, and Z. So these three people have, let's say, different values of some some asset. So let's say the value is X1, Y1, and Z1. This is the amount, and the value will be some P1, P2, and P3. So if we need to find the what is the average price or the average amount, so how will we do it? We will operate this X1 with P1, Y1 with P2, Z1 with P3. So then we will have the overall, like it will be basically quantity into price units, and depending upon whatever we want. So if we want the average price, so we'll add up the prices, total price, and we will divide. If we want the average quantity, we can divide it by the quantity. Simple case. So here we have different components. So like we have C1, slide something else. So we have C1, C2, C3, different components. So they will have certain percentages, P1, P2, P3, and then they have moisture content, so W1, W2, W3. So we will operate P1 with W1, P2 with W2, P3 with W3. So this is basically like even if you take the mass, so you can take some, assume some total mass of say 100 kg or even 1 kg is fine. So you can assume some total mass, you will find the amount of that component, then you can find the water content, and then like you can do it. So this may take some more time. So this is also how you can do it. So here we need to find basically the moisture content of the mix. So that will be summation of the water content into the percentage divided by the summation of the all percentages of the different components. So here I will vary from how many components we have. So we have 5 components. So 1 to 5, 1 to 5. So we need to operate P with W. So this will be 100. This will be 45, 12, 90. This will be how much? It will be, I think, close to 1700. I think. Yeah, so 1760. So now we need to add up all these values. So it will be 2007. So what we basically did was 20 into 5, 15 into 3, and so on till 32 into 55. Then we will divide it by the summation of the percentages. So 35, 38, 70, 100. So yeah, it is obvious also because since we are taking like all the components of the waste, so everything has been given. So all the percentages will add up to 100 only. So we'll divide by 100. So 2007 by 100, it will be around 20.07. So you can round it off to 20%. So coincidentally, that is also the slide number 20. So the answer is option A, 20. So answer was option A, 20. So this is not like related to some directly related to some lecture, but you may need this concept in solving the numericals. So here the thing I discussed with you. So here they have assumed moisture content directly 0.2, 0.15. So here they have divided with 100 directly, and then they are operating it with the given percentages. So 5, 3, 4, 3, 50. So this is also another way you can do. Whichever way suits to you, you can use that. So moving on to question 10. So which of the following types of solid waste can be biologically treated? Yard waste, agricultural waste, municipal solid waste, construction and demolition waste. So for biological treatment, we need two categories, so characteristics to be precise. So organic and biodegradable. So at least up to some extent it should be. Like it shouldn't be like 10% organic or 10% biodegradable. That is not ideal for a waste to be used on the biological treatment process. So yard waste will contain leaves. So leaves, as we saw, they are organic, they are biodegradable. So this we can treat. Agricultural waste, this will also contain like leaves will be there, weeds will be there. There will be some like some kind of organic sludge can be there from the fields. Also, like agricultural waste is just not about the waste which come from fields. So there can be other things also like fisheries, animal husbandry. So they are also treated as agricultural in some aspects. So from the waste from these also will go into these are organic biodegradable. So B also we can do. Municipal solid waste we know. So it will have organic components such as food waste. So that's also can be treated. So that is option C. Construction and demolition waste. This will contain things like wood, uh, leftover paints. So these are not organic or biodegradable much in any way. So actually wood is biodegradable, but it will not be easily get degraded. So biodegradability extent of wood is very low. So it takes time. So A, B, and C are correct. So these three types of waste can be biologically treated. So option A, yard waste, agricultural waste, and municipal solid waste. Students can refer to the fourth lecture of this week. So what all can we treat biologically? MSW, sewage sludge, agricultural waste, some sort of industrial waste, and also some kind of hazardous waste. So let us not assume that hazardous waste will be always chemical. There can be some biological hazardous waste as well, which can be treated biologically. Moving on to the next question, question 11. Which of the following components of municipal solid waste can be treated by a biological treatment process? So for there we discussed the like categories. Now we'll discuss the components. So plastics, paper, cardboard, and food waste. So as we saw in the previous question also, so municipal solid waste contains food waste. So that is organic, that is biodegradable. So we can treat it using biological treatment. So option D is correct. Cardboard also, it is organic and biodegradable, although not very much, but it is enough for getting treated. So C. Paper is also organic, biodegradable. So B, C, D we can use, but plastics we can't do that. So that will go with mostly recycle. So B, C, and D are correct. So paper, cardboard, food waste. Students can refer to the fourth lecture. Similar lecture, same lecture as the last question. So what are the biodegradable components that we will have, which we can use the biological treatment process on? So paper, cardboard, food waste, yard waste, wood, leather, and rubber. So there is a question mark. So that means like it takes time. So we need to take the judgment call whether we should use the process on them or not. So question 12 is a poll. So which of the following processes fall under the category of biological treatment? Low solids anaerobic digestion, aerobic composting, incineration, and recycling. Can quickly drop the poll. You can answer it in the chat also. We'll give 1 minute should be enough for this. Just like a memory-based question. You can answer it in the chat or the poll. Anything is fine. We'll wait for 1 or 2 minutes, then we will discuss that. Okay, so we have one response. C. Someone has answered B. I'll give a small hint. So two of the options are correct here, not just one. Okay. We have three responses now. So yeah, we can move on. So I will end the poll. So same topic, we are talking about biological treatment. So there will be different types of biological treatment. So first will be aerobic, then we will have anaerobic. So here there will be different types. So there will be like low solids, high sludge, or it can be high solids, low sludge. So different types will exist. Aerobic, we know that composting is a aerobic process. So which of the processes fall under the category of biological treatment? So aerobic we will have composting. So aerobic composting is correct. So option B. Anaerobic we will have low solids, high solids. Multiple types are there. So low solids anaerobic digestion. So A is also correct. So incineration is not basically a biological treatment. It's more like a thermal treatment. Recycling is not any kind of treatment. It can be actually of multiple types. Recycling can be thermal, chemical, physical. So all those types, but recycling generally, most of the cases will not be any kind of biological treatment. So D is not correct, C is not correct, A and B are correct. So low solids anaerobic digestion and aerobic composting. Same lecture, week 6, lecture 4 you can refer. So here you can see the processes. So aerobic composting, low solids anaerobic digestion, high solids anaerobic digestion, high solids anaerobic digestion, or aerobic composting. The combination of both also is possible. So now we will move on to the last question, question 13. So seeding is not an environmental factor important for producing good compost. So true and false. So seeding is basically we will mix some like what can you say? This just say simply new compost we can mix with some older processed compost. So that increases the efficiency of the composting process. So this old or processed compost that you are adding, so this is like a seed. So the process is called as seeding. So once the efficiency of the process we are seeing is going down, so we can mix some processed compost with it, so to improve the process. So seeding is here it is written not an environmental factor for producing good compost. So that is false. It is a important factor for the composting process. So the answer is false. You can refer to the last lecture of this week, lecture 5. So here we can see the blending or seeding process. So blending is the thing what mixing. So organisms are necessary for decomposition. So they are indigenous to the material. So we can mix 5% partially decomposed compost, which can speed up the process. Again, sludge is also good source that can be mixed as a component. So this was the last question for today's session. If you have any doubts, you can ask. Else, please feel free to log out. If you have any doubts, I would encourage you to ask. Otherwise, you can leave. Wait for maybe 2 minutes, then we will close the session. Okay, okay. That is a good question. Yeah, Soumya, I will get back to you on this. Maybe in the next class, we'll have answer for this. And I would suggest you to check out the website of, let me just see. You can check out the website for Central Pollution Control Board, CPCB. Sometimes they will post some internship requirements. Otherwise, you can always do some IIT or NIT. If anyone does not have any doubts, so we close the session now. Thank you everyone for attending the session.